In today's notes, we're going to take a look at parallel lines and then also to what the points on a graph for a line represent. So on the first page is parallel lines, and the star says to identify the slope and y-intercept for each of the lines to the right. Well, we can take a look at the equation. So this is the y-intercept. Remember, the equation is y equals mx plus b, where the m is the slope and the b is the y-intercept. Okay, you can also take a look at the graph. The point where the line intersects the y-axis is the y-intercept. So that's b, so the y-intercept is 2. The slope is represented by this number right here, the m, and the slope says 1/3. So to make sense of that, again, take a look at 2 points on the line. We go up 1/3. Up 1/3, up 1/3. So our slope is 1/3. The line that's parallel, okay, and below it, 1/3 x minus 1, it has a different y-intercept. It crosses at -1 instead of the 2. But it has, you notice, the same slope. So the slope is 1/3. Parallel lines are lines that will never intersect, okay? In order to not intersect, they must be the same distance apart throughout, okay? In order to be the same distance apart, that means they have to have the same slope. If they didn't have the same slope, okay, so I'll just draw a line on this grid that wasn't parallel, meaning let's start on the y-axis at 0, right at the origin. So a different slope, say, would be up 1/1, 2, 3, 4. Down 1, 2, 3, 4. If you draw the line that connects these points, okay, you can see they're not the same distance apart. We can't clearly see where they're going to intersect, but the intersection is going to be somewhere over here. As they move left to right, or as we read or look left to right, this distance keeps getting smaller and smaller and smaller and smaller and smaller. So eventually they're going to, if you continue, meet. Okay, so parallel lines are lines that will never intersect. So in the box, if the slopes of 2 lines are equal, then you can conclude that the lines are parallel. If you're told they're parallel, then you can conclude that the slopes are equal. So looking at question number 1, it says, are the graphs of y equals -1/3 x plus 5 and 2x plus 6y equals 12 parallel? Explain how you know. So this equation is really easy to read, y equals -1/3 x plus 5, or I guess interpret rather instead of read, because we can clearly see that we have a slope of -1/3 and a y-intercept of 5. In order to determine if it's parallel, I need to look at their slope. So I'm going to take this equation here and solve for y so I can look at it in terms of y equals mx plus b. So subtract 2x. I have 6y equals -2x plus 12. Okay. You could write 12 minus 2x, but I want it in the form y equals mx plus b, so I want the x term first. Divide by 6. 6/6 is 1, or 1y. Now I'm going to divide the 2 by 6. Okay, I can't divide, it doesn't go in equally, but I'm going to write its equivalent simplified fraction form. 2 goes into itself, 1 goes into 6 3 times. So this reduces to a -1/3, which is really all I'm worried about. Okay, so it does have the same slope. Okay, I want to continue solving though to see if it is the exact same line. 12 over 6 is 2. So since it's not the same exact line, okay, if it was, they wouldn't be parallel. But since they're different lines, they have a different b value, okay? So our m is -1/3 and our b is 2. I know they're different lines, and because they have the same slope, they are parallel. So are the graphs parallel? Yes. So since the graphs, or I want to say since the, I could say graphs, since the slopes of the equations are equal, the lines are parallel. Okay, so solve them both for y in terms of x. So put them in the form y equals mx plus b, and then take a look at the slope. Number 2 says, suppose the line with a y-intercept of -6 is parallel to the graph of 2x plus y equals 3. Write the equation of the line. So suppose a line with a y-intercept of -6 is parallel to that graph. Okay, write the equation of the line. So the line, we already know, has a y-intercept, or your b is -6. We need to know the slope. Okay, so I already have my y equals, I need my slope x, and I know it's going to be -6. That's my answer. So to determine the slope, I need to look at the equation that's given because it's parallel to that. So if I know the slope of this, I know the slope of my line. So to solve for y, I'm going to subtract the 2x, and y equals -2x plus 3. This is what I want, the slope, so I'm going to put my slope of -2 here. And we're done. So slopes of parallel lines are equal. On the back side, we're going to take a look at what all of the points on a graph represent. So reading in the box, it says, if an ordered pair xy satisfies the equation, which means it makes it true when you plug the x and the y in, then it falls on the graph of that equation. If a point xy falls on the graph of an equation, then it lies in the solution set. A line extends infinitely. So there's an infinite number of points that lie on the line. So therefore we have a solution set rather than just one point or one solution. It's a set because a line extends infinitely in both directions. So a graph represents all the solutions. So when you actually look at the line, that's representing all of the solutions to the equation. So number 1. Given the linear equation y equals 4x minus 3, does the point lie in the graph? Okay, so what we're going to do is substitute x is 2 and y is 5 into our equation. So does 5 equal 4 times 2 minus 3? Order of operations, multiply, so we get 8 before we subtract, and we end up with 5 equals 5. It works. Okay, so it came out to be true. So given the equation, does the point? Yes. Okay. When x and y are substituted into equation, the statement was true. Second one, is the ordered pair a solution to the equation y equals 1/2 x minus 3? Justify. Okay, so is the ordered pair, so we have x equals -8 and y equals 1. So I'm going to substitute, and does 1 equal 1/2 of a -8 minus 3? Multiply again before you subtract. 1/2 of -8 is -4, and -4 minus 3 is a -7. That does not equal the 1. So no. Justify, I don't need to explain in words. I have the work to show. The answer is no. The point is not on the line. Number 3, given the equation y equals 1/2 x minus 3, find the value of b given the fact that the point satisfies the equation. So this means the point is on the line. Okay, so I know that here x equals 4, and we're going to plug in the b for y and solve for b. So using the equation, b equals 1/2 of 4 minus 3. Half of 4 is 2, and 2 minus 3 is -1. So b is equal to -1. Number 4, and last one. The graph of the equation 2y minus 3x is shown. It's shown to the right. Name the 4 ordered pairs that are shown to be solutions of the equation. So those are all the points where we have a dot on the line. We have 3 dots that are actually marked. So those points from left to right, okay, this is, I'll write them over here, -4, -4. As we're moving from the origin left, 1, 2, 3, 4 down, 1, 2, 3, 4. The next one is left 2 down 1. So that would be -2, -1. The one to the right, we didn't move left or right, so that's 0 but up 2. And then 2, 1, 2, up 1, 2, 3, 4, 5. Next part. Determine another point that would be part of the graph. Show how you arrived at your answer. Well, if I take a look at, let me erase what I have. If I had to determine another point, okay, I would look how I moved from one point to the next, and I would use slope. So from here, I went up 1, 2, 3, over 2. Up 1, 2, 3, over 2. Up 1, 2, 3, over 2. Now, because it's a line, that rate of change or slope has to remain constant. So if I take a look at the coordinates here, which were 2, 5, or if I look every time, okay, my rise is being increased by 3. Up 3, up 3. So if you look, from moving from one y to the next, you're adding 3. -4 plus 3 is -1. -1 plus 3 is 2. 2 plus 3 is 5. So then 5 plus 3, okay, I don't have much room, is going to be 8. So I'm at the y-axis of 5, and I need to go up 1, 2, 3. That would be right here, and then over 2. So that would give me a y value of 8. The x's, okay, I keep moving left to right over 2, over 2, over 2. So I need to go over 2 from the x value that came before it. So let's just double check or show that. -4 plus 2 is -2. -2 plus 2 is 0. 0 plus 2 is 2. So now 2 plus 2 is going to be 4. So determine another point. So one of the points you could use would be for 8. In showing the slope and you're counting this rise over run every time, forgot my plus 3, that is the show part of that question. Show how you arrived at your answer.